Welcome to the ASHEPA HSE Roundtable, the platform where Africa's safety leaders share real stories, real lessons, and practical solutions. Today's episode focuses on one of the highest risk activities across telecom, energy, and construction work at height. Across Africa, thousands of workers climb towers, poles, scaffolds, rooftops, and elevated structures every day. And despite improvements in training and equipment, work at height remains one of the leading causes of fatal accident in our industry. But here's the truth. Most work at height incidents are preventable when engineering, planning, and training come together. I'm your host, Hussein Mohamed Fikry, and today we are joined by a valued ASHEPA member and HSC professional, Mr. Victor, to help us unpack the technical realities, engineering controls, and future of work at height in Africa. Joining us today is Mr. Victor, an electrical and telecommunications engineer with over 7 years of experience in occupational health and safety, telecom infrastructure, energy projects, and general work at height operations across Africa. He currently serves as the East Africa Manager at Gravity Group, where he leads safety operations, training, compliance, and risk management programs across multiple countries. Victor specializes in fall protection, rope access, rescue systems, electrical safety, hazard identification, and operational risk management, and has supported major telecom and energy projects including network modernization, infrastructure deployments, wind energy installations, and utility works. He holds a bachelor degree in electrical and communication engineering. He is pursuing master degrees in science in sustainable energy transitions and is an EBO certified SAQA accredited facilitator, assessor, and safety professional with deep expertise in competency development and emergency preparedness. Victor, welcome to the ASHEPA HSC Roundtable.
Thank you, Hussein. It is a pleasure to be here and to share this important conversation.
Thank you very much, Victor. As we all know, we will start with our first part, story-driven incident. So, Mr. Victor, before we talk about systems, engineering, and controls, I want to start with a story. Mr. Victor, can you take us back to an incident or moment in your career that changed the way you look at work at height safety?
Okay, thank you. Absolutely, yes. So, in my early career as a young supervisor, intern in a telecom organization, contractor, okay, so doing a network installation, I had a technical knowledge, but no formal safety training. So I approached this company for a safety, for installation work. They told me we'll send you to few sites. Once we've sent you to few sites, we can do an interview on you, see if you're capable of being our employee. Of course, I went to few sites, came back, having all the things on my fingerprints, technical know-how, how to do the installation. When I came back, to my surprise, I was not asked a question. The MD just asked me, "Do you have a driving license?" I'd honestly had a driving license, but I've never driven on a highway, not even more than 50 kilometers. And I was given a car. The first site I was assigned was 500 kilometers. So after being promoted to a team leader, I was sent to a site that is on the coast in the region. So in Nairobi, it is 500 kilometers out of Nairobi. So I was given an experienced rigger along with to go with me so that he can guide me as a technician, but I was the team leader. We were asked to proceed to site. We started the journey together with the guy. As we were proceeding, Along the way, we were asked to decommission a microwave dish around 400 kilometers. We received a call. We were told, please stop to the site, decommission a dish. So it was a big dish, 3-meter diameter microwave dish that is normally for long range communications. And this guy told me, this is very quick. We need to do it quicker. Then we proceed to Mombasa in the coastal region because there's a beach. We also needed to create time so that we can have enough time to enjoy ourselves in the beach. We were using a rope and a basic pulley system without a proper control. As the guy was releasing the dish, it had an H frame attached to it, the ODU attached to it, and it was very heavy, close to 200 kgs. As the dish was lowered, the load suddenly transferred to my hand because the guy was guiding me. How do you tie it along the tower leg? Okay, so it was almost lifting me off the ground. I quickly released the rope, but I had a fracture on my hand, on my finger. And actually, I have a mark on my finger since that, reminding me of that incident up to date. The guy told me we don't need to report this incident. And if I report this incident, he will report me back to the office and ask the management to send a new guy. This is my first job, imagine. So I have to tell the guys, okay, I will follow what you tell me. We proceeded to Mombasa, remaining 400 kilometers. And the following day, when we were doing installation again, we were removing the single band antenna, we replacing with the quad band antennas. As I was holding the rope with my hand, the following day, the same injured hand was hit again by a dropped carabiner. The guy released carabiner on the top and hit the same spot. That experience opened my eye. We had no proper risk assessment, no lifting plan, no rescue plan, nothing at all. We were depending on experience. I realized that even experienced people can be exposed if the right systems are not in place. I was being pushed by something to keep reporting this incident. I reported the incident eventually to the management that employed me. Luckily, the company responded positively and sent a support. Their moment shaped my safety journey. Today, my message is very simple. Worker tight must never rely on assumptions. We need competent supervision, proper planning, the right equipment, a culture where people feel safe to report incidences. A drop object can cause damage, like we damaged the dish. It can cause a serious injuries. I fractured my fingers, and it can even lead to fatality. Just imagine if security guard who opened us the gate was closer by, it could be hit, and that we could be talking into a different thing, or it could even be myself. Or luckily, thank God, I ran inside the tower, and the dish had to fall in a different direction. Thank you, Hussein.
Thank you, Victor. What stayed with you most from that experience, the event itself or what you realized afterward?
Okay, what stayed with me is not just the injury itself, but the realization afterwards. I understand that safety cannot depend only on someone's experience or confidence. We went to site with confidence, remember? I was a supervisor myself, responsible for the safety of myself and the technician that I was given. But I had not been equipped with the right safety knowledge. We had experienced people, but we lacked the proper planning, no risk assessment, and no right control. The experience changed my mindset. I learned that a good safety culture starts before the work begins, with preparation, competence, and communication, and making sure everyone goes home safe.
That is completely true. I completely agree with you, Victor. Looking back now, were there early warning signs, near misses, or patterns that were missed before the incident that happened?
Yeah, thank you for that. There were so many warning signs that we ignore. The biggest one was that we were relying on experience instead of proper safety process. We had no formal risk assessment, no lifting plan, no rescue plan, and we were using equipment that was not suitable for the task at hand. The assumption was that because the guy is experienced, actually the guy was close to 30 years experience, and I was just starting my career. The lesson I took from that experience is important, but it must be supported by the system. Good planning, the right tools, proper controls, and what are what prevent incident before they happen.
That is true. Experience by itself alone without the proper knowledge and tools is no use. Agree. Would you say that this experience is what pushed you to focus more on engineering controls and system design rather than relying on only training?
Yes, big time. It was a major turning point for me. It taught me that training alone is not enough. We need strong systems, proper equipment, and engineering control that reduce the human judgment. Training is important, but a good safety comes from designing our work to prevent incidents before they happen.
Yes, that's a powerful insight, and it brings us directly to today's core topic. So, Mr. Wilson, would you like to add any point with Mr. Victor?
Yeah. Okay. So, Victor, you are a trainer, work at height
Mm.
trainer.
Mhm.
If someone join your training and has no experience at all, how do you bring the person's mind to the risk, the kind of risk that work at height involve?
Okay. So we need to have a curriculum that is competency based, not in a controlled environment. So we have to simulate what exactly happens on site. If you train somebody now in a controlled environment, he doesn't have experience. When I mean experience in the field, we got the wind speeds. When someone is at height, there's a wind speed. There is electrical hazard. There is poor anchor systems. There's rusted members on the. How do you capture all those? There is pressure as well and the field. And you are in telecom as well. You can bear with me. The pressure of ensuring the site is completed is something else. So how do you incorporate that in the training so that you simulate the real site scenario? So that's, to me, I love to ensure I simulate that site scenario when the guy is undergoing my training, so that even if he leave the training and is going to be on site, he can actually relate. Honestly, this is what I studied, and this is what I learned, and this is how I was taught how to tackle it. Yeah. So it is the training versus the real scenario in the site.
Great.
Yes, this is a very important point. Okay, ladies and gentlemen, now we go to our technical deep dive at working at height. Victor, what are the biggest technical and operational challenges currently affecting working at height in Africa, particularly in telecom, energy, and construction sectors?
Okay. To me, the biggest one is inconsistency in competency levels. Okay. So, and with lack of engineered access solutions. So many sites still rely on training. I trained my guy, he has a paper. Okay. So that paper is just showing that you went through the training, but can you actually do that work? Okay. So that's how most companies approach it, and that's how most the bigger African challenge is. They doesn't match the proper anchor system, the proper rescue planning on site, and equipment standardization. In telecom and energy sectors, and you can bear with me this, we also see pressure to reduce the downtime, which often leads to unsafe shortcuts. Okay? The real gap is not awareness, it is the lack of integrated engineered safety system combined with competency based training.
Okay, so how does gravity approach the engineering of work at height systems differently compared to traditional training providers in terms of risk reduction and system design?
Okay, thank you. Thank you for that question. At Gravity, we do not treat worker type as a training. We treat it as a system engineering discipline. We integrate access design, anchor points engineering, fall protection system, and user competency into one solution. One approach starts with hazard mapping, followed by selection of engineered anchorage, compatible PPE system, and task-specific movement techniques. This reduces dependency on human behavior. Okay? This shift into engineered control systems. Hussein.
Amazing. It's great to hear this. Thank you, Victor. Many workers are trained, but still injuries happen on site. What gaps do you see from your experience between training standards and real operational conditions in the field?
Most training fail because it is delivered in a controlled environment, as I mentioned earlier, that do not reflect the real operational complexity. Wilson has worked in telecom. He will tell you when someone has climbed from 20 meters to 30 meters to 50 meters, 60 meters, even to 70 meters, the altitude differs. The wind loads, the poor structures in the coastal region, the rusted platforms. The guys in the fiber environment are working close to electrical exposures. The time pressure as well to ensure the site is sorted within the time frames. Workers often return to site where anchor points are uncertified. Some even work without a proper rescue plan. There are no rescue at all on site, and supervision is minimal. No one to supervise them. The gap is between certification and field readiness. If something goes wrong, is the team on site able to do it, or we just having the papers? And that's why I wanted to answer you. At Gravity, we just not focus on that training. We focus on scenario-based training that replicates the real conditions, including the stress, the time, pressure, and the rescue constraints on site. Hussein.
Yes, that is a very big gap. Agree, Mr. Victor.
Yeah.
Can you explain to us how proper anchor point selection and lifeline system design directly influence fall factor reduction and rescue efficiency?
Okay. Anchor point selection is critical because it determines the fall factor, the shock load, and the fall distance. When I mean the shock load here is the maximum weight that will be distributed in the body when the fall is arrested. Okay, the anchor point is just a point where you are touching your equipment. It can be your shock absorbing hooks. It can be where you putting your anchor sling when you're doing the rigging purposes, for example. Okay, so when it comes to the fall factors, we normally calculate it as the distance of fall divided by the distance of the shock absorbing lanyard of the fall arrest devices you are using. So it is important to achieve the zero fall factor as much as possible. That is the shortest distance, normally above your head, also that the fall arrest systems you're using, if case fall occurs, the weight does not get distributed to your body. Okay? A correctly positioned anchor points above the user reduces the fall factor. So we normally have got the three fall factors, 0, 1, and 2. And we must aim towards 0 as possible. This is because it will significantly reduce the fall arrest force. Incorrect anchor placement increases pendulum. Okay, so effect and shock load on both the user and the structure.
Yeah, this is a very, very deep technical point. Mr. Wilson, would you like to comment?
Okay, so Mr. Victor, what are the critical safety controls and sequencing steps in modern tower erection project that most companies in Africa overlook?
Okay, when it comes to tower erection, it needs a very proper way of doing it and a very proper plan in place. The most critical overlooked steps are sequencing control, okay? The load path, verification, and temporary stability system during erection phases. Many failures occur during intermediate stages where you're moving from one stage to the next. It's not even about the final stages of completion. Proper rigging plans, control bolting up, sequencing, wind condition monitoring, and exclusive zone enforcement are essential. We emphasize engineered lift planning and structural stability checks at every stage, not only at the final stage. So when the guys are moving from the first stage, it is properly stable structure when you move it to the next one till its completion. Another challenge the guys have been experiencing when it comes to the tower erection is how do you secure yourself when you building up the tower? So because you realize your fall arrest system falls short, you cannot find a place where to hook them. And that's where the modern way, you introduce the lifeline systems on the guys. You also, how do the guys use lifting gene pole when they're doing the rigging purposes? Use of the light gene pole. Over the past, you realize even the guys use the tower leg, which bends, and finally you become up with a tower that is skewed. Wilson.
That's true.
Thank you, Victor. Okay. It's very important for us to know also how gravity is involved in manufacturing and sourcing work at height PPE. What technical standards and innovations are you focusing on to improve performance in African environment?
Thank you for that question. Just wanted to maybe put it this way. Gravity is divided into three companies. The training part, the global part that deals with the anchor systems and the design, the bolting services. We also have the gravity gear that designed and manufacture the work at equipment. Their main focus is the durability in African environment. That is, we're talking about the UV resistance, the corrosion protection, and the thermal performance. We also prioritize compatibility between PPE systems, ensuring harnesses, example, and connectors and the lanyard functions as a complete system rather than standalone components. Innovation is moving towards modular systems, energy-absorbing connectors, and hybrid material that reduce the weight while improving fall arrest performance. Another thing that is being done is use of smart PPEs as a safety inspector or a safety manager in their office, and the guys doesn't report incidents on site. You do regular PPE inspection. We've introduced the smart PPEs whereby if there's a fall on site, you can easily pick it up when you're doing inspection if it was not reported. So those are some of the new things that are coming up in the PPE design and manufacture.
Thank you. This is very important. Having also smart ways to detect any issues with the PPE is very important. Mr. Wilson.
So, Victor, in your view, when should rope access be preferred over scaffolding or MEWP system? And what technical limitations must engineers consider?
Okay. Thank you, Wilson. Rope access is more suitable for complex geometries. So in areas where your fall arrest falls short, you cannot use your, fall arrest is where you're climbing using your hands, your feet, and you're using a fall arrest system. In case fall occurs, you got a fall arrest system that catches you and prevents you from falling on the ground. But we got areas where you cannot use the fall arrest way to access a height distance. Okay, for example, you're working on the wall-mounted sides, you're working on the side of the building to put cables, or you're cleaning the windows, you're washing the window, you're painting. At that areas, you cannot use your fall arrest means. So that's where the rope access comes in. High-rise structures, okay, and rapid deployment environment where scaffoldings or MUPs are also impractical. You can use the rope access. However, it requires strict control for anchor integrity. For rope access to proceed on site, you must have a level 3 to supervise the work that is going on site. That's where the anchor point integrity is very key. Scaffolding is normally okay, better for long-term duration. But again, you must be ready to invest on the cost that comes with it. The guys who are using the scaffolding must be trained on scaffolding use. You must have scaffolding inspector, and you must have scaffolding erector trainer. Trainings as well to erect, and you must have a scaffolding inspector as well to just ascertain the scaffold have been properly erected and is good condition. While the MUPs, the mobile elevated work platforms, are also ideal for repetitive lifts. Okay, engineers must evaluate structural access feasibility, rescue time, and environmental constraint before the selection.
That's great. That's good.
Thank you.
Yeah.
Thank you. It's really getting more interesting. So, how should electrical hazard awareness be integrated into rope access and pole climbing training, especially in telecom and power distribution environments?
Okay, thank you, Hussein. Electrical awareness must be fully embedded into our watertight systems, especially in telecom and distribution environment. If you look at the guys who are doing the fiber installations, it can be fiber to the home, fiber to the building, or fiber to the to wherever the project, the FTTX projects. The most of the modern or the most of the MNOs, the service providers, they use the electrical lines to lay their cables, and these technicians, they work close to electrical wires. Okay, this include minimum. How can the guys work close to electrical wires without getting electrical shock or without being exposed to electrical hazards? Okay, so we're talking about safety of working close to electrical wires. So they might be taught on a worker tight, climbing falls, use of ladders, but do they have electrical awareness? This includes minimum approach distance, non-conductive equipment selection, and isolation processes when they're working in such lines. Training must simulate the live line proximity risk, not just theoretical discussion. And that's why at Gravity, we integrate the electrical hazard mapping into all climbing and rope access modules to ensure dual risk competency.
Yes, this is very important. Working beside electricity is very, very high risk. Mr. Wilson.
So, thank you very much. So far, I think we are learning so much. Myself, I've taken a training from Gravity before, and I was taught by Mr. Victor. So I know he's a highly competent trainer, and I really appreciate the work he's doing to support health and safety in Africa, and also ensuring that people doing work at height work safely. So now, Mr. Victor, let me ask you, what is the most overlooked technical element in rescue planning for work at height operations, and how can companies improve readiness?
Thank you, Wilson, for that question. The most overlooked element is rescue execution time versus accessibility of the systems. Many companies have rescue plans but lack immediate deployment systems or trained standby responders. Rescue systems must be pre-rigged or rapidly deployable within minutes. And that's why at Gravity, we emphasize on self-rescue capability, assisted rescue systems, and pre-installed descent mechanism as part of design, not afterthought. Wilson.
Great.
Thank you, Victor. Unfortunately, and I'm sad to say, will be our last question in our technical deep dive. We are enjoying the session with you, Victor. So, from your view and experience also, where do you see the future of work at height engineering and training in Africa? And what role should companies like Gravity play in setting industry standards?
Thank you, Hussein, for that very good question. I'd said earlier, the future is shifting towards engineered safety ecosystems, not just isolated training. These include integrated anchor system, certified PPEs manufacturing, digital monitoring, and competency tracking. Africa is moving towards stricter compliant frameworks, especially in telecom, energy, and infrastructure. At Gravity, the Gravity's role is to set standards in both training and engineered access systems, bridging the gap between compliance and operational efficiency and field safety performance. So we want to ensure a proper standard cutting across different industries, different countries, so that we ensure people are doing the same thing at high level. The focus is quality, safety, and operational efficiency. Hussein.
Thank you, Victor, very much. We wish you all the good luck and in your mission and vision with Gravity. Ladies and gentlemen, now we move to the fun part with rapid fire questions. So I will ask you questions. It's a fast question. We need a short answer with the first thing that comes in your mind. So I will ask the first, and then Mr. Wilson will ask the second, and so on until we finish. So the first thing that comes on your mind, just answer. So are you ready?
Yeah.
Okay, so the first question, one myth about working at height you want to break.
Okay, thanks for that question. The myth straight away, experience alone doesn't one myth guys talk about here, experience alone makes someone safe. Competency planning and controls are what keep people safe. That's a myth.
Great.
That's great. That's great. So, Victor, so what mistake you see most often during tower or roof top work?
Oh, thanks. The main mistake here is starting work without proper risk assessment, without rescue planning, without checking the right equipment. You're starting the work without inspecting the equipment you're using. That's a mistake a lot of people do. Wilson.
Okay. One early indicator that a serious fall could be coming.
Okay, thanks, Hussein, for that. The biggest indicator is shortcuts. Guy is taking shortcuts. When people start bypassing procedures, that's where you see the big problem starting. Yeah.
Okay, that is true. Very, very true. So, one skill every work at high technician must master.
A technician should be able to properly identify the risk and hazards, mitigate them before the work starts, making the right decision before climbing. That is a very big skill every technician must have.
Yes, because that speaks that they say in health and safety, if we don't have hazard, we don't need health and safety professionals. So if you are not able to check the hazard and identify them, then there's a big problem. You cannot even move to the next step.
Agree 100%. And finally, one message you want every African safety leader or all safety leaders across the world to remember.
Okay, good. Let me talk to safety professionals, the safety managers. I just want to make it clear, safety is not a document in the office. It is a daily behavior. Plan work, control the risk, and make sure everyone goes home safe. These people have families. They are our sisters. they are our brothers, they are our parents, example, and they need to get home safe. They need to go back to their family, get to the field, see what exactly is happening, get the real touch with the guys. Safety is not a document back in the office and just sit in the office. Thank you.
Yeah, very, very important message. Mr. Victor, we thank you very much for sharing both your experience and your technical insight with us today. Your message is a strong reminder that work at height safety is not just about harness and training, it's about engineering, planning, safety design, and understanding the realities of African work sites. And not only experience is enough. Experience definitely alone is not enough. Mr. Wilson, would you like to add anything at the end before I end the round table for all ASHEPA members?
Thank you, Hussein. So what I want to add is that as a safety professionals, like Victor said, safety is not desktop work. It's not tick box work. We need to be at the site. We need to identify the hazard. We need to help the team and the challenges that they face and help them work together, consult them, because they are at the front line. They know in reality what is happening. And we have to be on the ground to make sure that the work is done safely, not sitting in office and giving command and checklist and big document and expecting that people will work safely. So as health and safety professionals, we have a duty to make sure that everybody goes home safely to their family, and one life saved is millions of life impact.
Thank you very much, Mr. Wilson. So, to our listeners, we thank you for your time. We hope this wonderful session is an added value to each person who is listening. We want to remind you to subscribe to our YouTube channel, watch the video, share the knowledge with all your teams, colleagues across, and we hope that we are able to change culture across Africa. And this is part of our vision and role in ASHEPA. Again, thank you for your time, Mr. Victor. Thank you, Mr. Wilson, for your time. This is ASHEPA HSE Roundtable, where Africa's safety leaders speak.